A star is an astronomical object comprising a luminous spheroid of plasma held together by self-gravity. The nearest star to Earth is the Sun. Many other stars are visible to the naked eye at night. Their immense distances from Earth make them appear as fixed points of light. The most prominent stars have been categorized into constellations and asterisms, and many of the brightest stars have proper names. Astronomers have assembled star catalogs that identify the known stars and provide standardized stellar designations. The observable universe contains an estimated 1022 to 1024 stars. Only about 4,000 of these stars are visible to the naked eye, all within the Milky Way galaxy. A star's life begins with the gravitational collapse of a gaseous nebula of material largely comprising hydrogen, helium, and trace heavier elements. Its total mass mainly determines its evolution and eventual fate. A star shines for most of its active life due to the thermonuclear fusion of hydrogen into helium in its core. This process releases energy that traverses the star's interior and radiates into outer space. At the end of a star's lifetime, its core becomes a stellar remnant, a white dwarf, a neutron star, or, if it is sufficiently massive, a black hole. Stellar nucleosynthesis in stars or their remnants creates almost all naturally occurring chemical elements heavier than lithium. Stellar mass loss or supernova explosions return chemically enriched material to the interstellar medium. These elements are then recycled into new stars. Astronomers can determine stellar properties, including mass, age, metallicity, chemical composition, variability, distance, and motion through space, by carrying out observations of a star's apparent brightness, spectrum, and changes in its position in the sky over time. Stars can form orbital systems with other astronomical objects, as in planetary systems and star systems with two or more stars. When two such stars orbit closely, their gravitational interaction can significantly impact their evolution. Stars can form part of a much larger gravitationally bound structure, such as a star cluster or a galaxy. The word star ultimately derives from the Proto-Indo-European root H2STR, also meaning star, but further analyzable as H2AS, to burn, also the source of the word ash, plus ter, agentive suffix. Compare Latin stella, Greek aster, German stern. Some scholars believe the word is a borrowing from Akkadian, Ister, Venus, however some doubt that suggestion. Star is cognate, shares the same root, with the following words: asterisk, asteroid, astral, constellation, Esther. Although stellar parameters can be expressed in SI units or Gaussian units, it is often most convenient to express mass, luminosity, and radii in solar units, based on the characteristics of the Sun. In 2015, the IAU defined a set of nominal solar values, defined as SI constants, without uncertainties, which can be used for quoting stellar parameters. Nominal solar luminosity L is equal to 3.828 times 1026 W, 54. Nominal solar radius R is equal to 6.957 times 108 m, 54. The solar mass m was not explicitly defined by the IAU due to the large relative uncertainty, 10⁻⁴, of the Newtonian constant of gravitation g. Since the product of the Newtonian constant of gravitation and solar mass together, gm, has been determined to much greater precision, the IAU defined the nominal solar mass parameter to be. Nominal solar mass parameter, gm, is equal to 1.3271244 times 1020 m3/s2, 54. The nominal solar mass parameter can be combined with the most recent, 2014, Kodata estimate of the Newtonian constant of gravitation g to derive the solar mass to be approximately 1.9885 by 1030 kilograms. Although the exact values for the luminosity, radius, mass parameter, and mass may vary slightly in the future due to observational uncertainties, the 2015 IAU nominal constants will remain the same SI values as they remain useful measures for quoting stellar parameters. Large lengths, such as the radius of a giant star or the semi-major axis of a binary star system, are often expressed in terms of the astronomical unit, approximately equal to the mean distance between the Earth and the Sun, 150 million kilometers or approximately 93 million miles. In 2012, the IAU defined the astronomical constant to be an exact length in meters, 149,597,870,700 m.